Alright, so BGP has got loop prevention mechanism. It has got some loop prevention mechanism. For IBGP, the loop prevention mechanism, we call it as a split horizon. But this split horizon is different from the split horizon that we saw in RIP. They are not the same. Split horizon in BGP, in especially IBGP, we don't have split horizon for EBGP. Split horizon in IBGP, it's different. It's not the same thing that we saw in RIP. Split horizon in IBGP. What does that split horizon in IBGP says? It says route learned from an IBGP should not be given to other IBGP. Very simple. Route learned from one IBGP should not be given to another IBGP. What it means? Let's take 3 or 4 routers. Okay, 5 routers. Now, and I make this as AS20 and this one as, let's say, AS10, and they are connected like this. They are connected like this. It can be like this. It also can be like this. Same 4 router using a layer 2 switch. Now, this or this. If it is like this, you really no need split horizon to be active. We don't want split horizon to be active if you have like this. Why? We won't have loop if we have something like this topology. But when we have this type of topology, there are chances for loop. How? Let's say update is coming to this router. The update that comes to here will be given to this, this, and this, because they are connected to a switch, a layer 2 switch. Now, the update that this has received on this router, what this will do, this will send to everyone other than from where it is coming. Like same update, it is forwarding again to this and to this. Even this also has received the update like this. So what this will do, it will also forward to this and this. Likewise, this will also forward the same update to this and to this. And the update that was coming from here, the green one, will be forwarded from here to this, to this, Likewise, there is a duplication of updates sent again and again to all the routers repeatedly, which forms loop. To prevent this loop, what IBGP says is, let's have split horizon on it. That's what IBGP says. Let's have a split horizon. If we have split horizon, problem solved. What it is? What is split horizon? Even in RIP, what we know about split horizon: the route learned from one neighbor on an interface should not be advertised via the same interface. Same principle here. The route learned from an IBGP should not be given to other IBGP. This is the split horizon in BGP. Now let's take the same topology once again and talk about the update with split horizon. Now we got 4 routers. We got 4 routers. We have a switch. Now update is coming. When this router gives the update, it gives to this guy, this and this. That's all. Problem solved. What does it say? Route learned from an IBGP. This and this are IBGP. Likewise, this and this are IBGP. Likewise, this and this are IBGP. Route learned from one IBGP should not be given to other IBGP. So this is not going to give the update, and there is no duplication. There won't be duplication. So to avoid this problem, looping problem, only we have the split horizon. It is good. Split horizon is good in IBGP. It solves the loop issue. In LAN we always have loop. So this loop has to be fixed. That's why we have this split horizon. But that split horizon is no good in this design. It's not good in this design. Let's say we have A, B, C and D. When an advertisement comes here to B from AS20, B will give it to A. So B and let's say this is F. B and F are eBGP neighbors. They don't have any problem. But B and A is IBGP. Likewise, B and C is IBGP. So the route will be given to A as well as to C. Now this A and this D are IBGP neighbors. This A and this D are IBGP neighbors. Likewise, C and D are IBGP neighbors. What a split horizon says, whatever you learn from one IBGP, you should not give to other IBGP. You should not give to other IBGP. So routes learned from B on A, the route that is learned on A from B will not be given to D. Route that is learned on C from B will not be given to D because of this split horizon will not be given to D. So we need a solution. What is that solution? We make it fully mesh. Fully mesh. Now, is this fully mesh? No. D and A, D and C are neighbors. Likewise, A and D, A and B are neighbors. Likewise, C and D, C and B are neighbors. This is not fully mesh. What is fully mesh? D also, see here you got D as a neighbor with A, D as a neighbor with A, and D as a neighbor with C. We don't have neighbor between D and B. There is no neighborship between B and D. There is no neighbor. Similarly, there is no neighbor between A and C. There is no neighbor. Because we don't have neighbor, the route learned from one IBGP will not be given to IBGP. This rule you cannot override. If you form B and D as a neighbor, B will directly give to this IBGP. D need not to wait for A or C to give the update. It can take from B directly. Why? It's a neighbor to B. When I make B and D as a neighbor, the route will be given to D. Now, for having the route on D, do I need to have a physical cable between D and B? No. I need not to have a physical cable between B and D. All that I need is a logical connection. What is a logical connection? I need to go to B and say your neighbor is D. The loopback address of D. Why I use loopback address? Because we have redundant links. You remember on the previous class I explained why we use loopback interface address. And when you use loopback interface address, we will say update source command. Now, we go to B and say the address of D, and likewise we go to D and say the address of B. When we say that, TCP packets will be sent. Updates will be sent as TCP packet from B to D directly. How it can go directly? It will anyway go through A. A will be forwarding it, but the packet is destined to whom? D. Though packet is going to go via A or via C, still B and D have direct handshake. Though they are not physically connected, they have logical connection. Because it's a TCP protocol, this is possible. So we need to do what? We need to fully mesh. The reason why we make fully mesh, why I need to go to A and say CS neighbor, though it is not directly connected, I need to say CS neighbor. The reason is, if an update comes to C, it will give to A. By doing so, we override the split horizon issue. So, when you don't have a layer 2 switch in the middle, make sure you have fully mesh in IBGP. Otherwise, routes will not be learned from A to D and C to D. Is that clear? Any doubt in this? Any doubt? Okay. Yes. Yes, I'll do it. I'll summarize. Now, in BGP we have something called split horizon. Now, why we have that split horizon? In order to prevent loop. When we have a layer 2 switch, and when routers are connected like this, and these routers are what? IBGP routers, IBGP neighbors. Router 1, router 2, router 3, router 4. So when an update comes from external source, when an update comes from EBGP, the update has to be sent to IBGPs. So it sends to this IBGP, and this IBGP. Now what they will do when they receive the update, they will send to the other neighbors. So R1 will send to R4, R3, and whatever comes from R1, R4 should send to R3 and R2. So there is a duplication of update going again and again, reverse flowing. This is loop. To prevent this, how BGP is designed is, BGP is designed not to give the routes that learn from one IBGP should not be given to other IBGP. It can give to other EBGP, but it cannot give to other IBGP. See, if I have one router here outside, the route that is coming from here will be given to R1 R1 will give to the eBGP neighbor, which is external, some other autonomous system. Let's say this is autonomous system 30. It is coming from autonomous system 10, and this is autonomous system 20. It will give to autonomous system 30, but it will R1 will not give to R4, will not give like this, or it will not give like this. It's a good thing. It solves the problem. Because R2 is neighbor with R1, R4 and R3, whatever R1 receives, R4 also going to receive, R3 is also going to receive. That's all. They don't propagate further. It is good. It keeps the loop away. So split horizon is good. But when it comes to this type of design, this is 20 AS, this is 10 autonomous system. When an update comes from here, R2 will give to R1 and R2 will also give to R3. R1 and R4 are IBGP neighbors. R1 and R2 also IBGP neighbor. So what happens, whatever R2 gives to R3, R3 is not going to give to R4. The reason is the route learned from one IBGP. You may say R2 is an eBGP. No, R2 is not eBGP with R1, with R3. R2 is not eBGP with R1 and R3. It is an IBGP. It is eBGP only with this X router. So route learned from one IBGP should not be given to other IBGP. That is what split horizon. Because of that rule, R4 will not learn the route given from X router. R1 will learn, R3 will learn, and R3 and R1 will not give to R2 due to that split horizon rule. So how can you override this rule? Make R2 and R4 as a neighbor. I am not asking you to put a physical cable. Go to R2 and say, as you said R1 as a neighbor, you also say R4 as a neighbor. That solves the problem. As you said R3 as a neighbor, you also need to say R4 as a neighbor, which is called fully mesh. Now if I make neighbor between R1 and R3, if any external route comes to R1, R1 will give to R4, R2 as well as to R3. Direct feeding. So here no need of an IBGP to forward to another IBGP. We are not cancelling split horizon. We are finding a solution. Split horizon is good, so we don't want to cancel it. We are finding an alternate way to get the route on R4. By doing how? By making R4 and R2 as the IBGP neighbor. This type of logical connection is what needed. This is what fully mesh logically. These two are not physical cables, just the neighbor command. Now these things are very well explained in those videos that I have shared you. I want you to go through those videos and do parallelly. Right. And one more thing, let me explain. We got, let's say, 4 or 5 routers in an autonomous system connected like this, and this is in autonomous system 10, and here it's connected to autonomous system 20, and here it is connected to autonomous system 30. Now we have a network behind 30 called 3.3.3.3. we have a network behind this one called 2.2.2.2, and let's say this as 33, router number 33, this is router number 22, this is 1, 2, 3 and 4. Now 22 is advertising 2.2.2.2. It is advertising. So router 3 learns about 2.2.2.2. Now let's say router 2 is BGP enabled and 3 is BGP enabled, and router 2 and router 3 are IBGPs. Likewise, router 2 and router 33 are EBGPs. So now what happened? 22 is advertising the route 2, router 3. So router 3 knows about 222. Likewise, 33 is advertising about 333. So router 2 also knows about, router 2 knows about 3.3.3.3. Alright. Now router 2 gives the update 3.3.3.3 to router 3. So router 3 learns about 3.3.3.3 from where? Router 2. So whatever is learned from R2, I'll write in green color. 3.3.3.3 is learned. Whatever is learned from router 3, I'll write in green color here. 2.2.2.2. Okay. Now they have learned the route from the left will be learned on the right. So because R3 knows about 333, it will advertise to 22. Now 22 has learned about 3.3.3.3. Now because you have this route in the routing table, now you can ping. Likewise, router 33 is learning about 2.2.2.2. From where? From router 2. Alright. So this is advertised to 33 and this is advertised to 22. Now both routers on the left and right, they know about their destination, how to reach their destination. So according to 33, if it wants to go to 2.2.2.2, all that it needs to do is it needs to send the traffic to whom? Router 2. And router 2 will send the traffic to whom? Router 3. And router 3 will send the traffic to 22. Similarly, to reach 3.3.3.3, 22 need to forward the packet to router 3. Router 3 will forward it to router 2 and router 2 will forward it to 33. Now, they should ping, but it will not ping. Why? Now, why I'm explaining this scenario is, I want to make you understand why I need to enable BGP here. See, we don't have BGP here. So these routers have no chance of learning about 222.333. Router 1 and 4 has no idea about these two networks. Because they don't know about that, when R2 forwards the packet to R3, where it will forward? It will forward to router 1. See, if R2 wants to go to router 3, I'm pinging from here, 2.2.2.2. 33 will send to R2. R2 wants to send it to router 3, but if it wants to go to router 3, it needs to take the path via 1 or 4. So it forwards the packet to 1 or 4, and in router 1's routing table, there is no destination called 2222. Likewise, when I ping from here 3333, packet is sent to router 3 and router 3 wants to send it to router 2. It has to go via router 1 or router 4. When it sends to router 1, it has no idea where is 333. So what happens? The packet will not be passed. for this reason. I want this router also to know about what? Those routes. If I want to know about those routes, what is the way? Enable BGP. You may ask me a question. Already you are running OSPF on these routers, which we saw in the previous class. We are running OSPF on these routers because you have OSPF router 2 and router 3 has already formed neighbor. Now do I need to enable another routing protocol BGP? Yes. Yes. This OSPF is not going to really distribute the routes for 222 and 333. It is BGP. So you need BGP. OSPF has no idea about 22222, 33333. If you want 22222 and 33333, because you are learning from BGP, you need to have BGP on all the routers. So now, because I have BGP here, IBGP here, now all these routers, and it needs to be fully meshed. When we configure BGP on router 3, I need to say, I have a neighbor called router 1, I have a neighbor called router 2, I have a neighbor called router 4, I have a neighbor called 22. Fully mesh. All should be neighbor. Even not directly connected router need to be. So when we have something like this, fully mesh, pinging from here to here is possible. So we have seen two things today here. One, why I need to have BGP on every router inside an autonomous system. BGP is for borders. Between border, it's a EGP protocol. It's a protocol that works between two routers in different autonomous systems. Then why I need BGP on all the routers inside my autonomous system? I need because these routers in the path needs to know the route that is given by BGP. If you want to know the route given by BGP, I need to have BGP. Only then I can learn from BGP. You may also say like this, whatever I'm getting from BGP, I'll put it into OSPF. OSPF is already there. I'll give to OSPF. That's called redistribution. I'll redistribute to OSPF. And from here again I'll redistribute from OSPF to BGP. No, that's not a good idea. Why? OSPF has no idea about the attributes of BGP. According to OSPF, there is only one metric. What is that? Cost, based on bandwidth. It knows only cost. So when I redistribute BGP into OSPF, I lose all the attributes. It's not a good idea to redistribute from BGP to OSPF and OSPF to BGP. That also consumes a lot of processor when you redistribute from such a big protocol to a small protocol and back from small to big. Not really fair. So we have to enable BGP on all the routers in the path. Plus, if I have something like this, it needs to be fully mesh. Logically, it's to be fully mesh. When we have something like that, we can ping from here to here. Now, I'll ask a question. Any one of you can answer. Physically, it is like this. Autonomous system 20. This is layer 2 switch. Now, do I need to have fully mesh in this? Is there any need for fully mesh inside this autonomous system? Good answer. Why? So, can you explain more? Let me say I got a network called 1.1.1.1 and 2.2.2.2. advertised from X and Y. Okay, now you explain. Yeah, Pope, you can use this and explain. So according to you, we need BGP here and BGP here, and these two are IBGPs, and these two are. No, we don't disable split horizon in in BGP. We never disable it. Okay. Now we don't have BGP here. No BGP. No BGP. That's a good answer. We no need to have BGP here. Now why? Absolutely right. So you see, this 111 is advertised to router 2. Router 2 will advertise to router C, and router C will advertise to router X. And if X wants to ping 1.1.1.1, the packet will be sent to C, and C can directly send it to A. It is not going through B. So not necessary at all. So we need to have fully mesh only when we have this design. We don't have a layer 2 in the middle. So hope this is clear, and this is very well explained, means demonstrated in our videos. I want you to go through those videos. I'll pick the video once again for you, which covers this portion, and I'll post it after this class. Go through that video, try doing by yourself. Now, one more thing, very important foundation thing we are going to see now. What is that? Now, let's say I have router 1 connected to router 2, and that has got 12.0.0.0 network /8. So 12.0.0.1, 12.0.0.2. And this router 2 is connected to router 3, 23.0.0.2, 23.0.0.3. And router 3 is connected to router 4, 34.0.0.4, and 34.0.0. So 3 here and say 4 here. Okay. Now, this one is autonomous system 10. And this one is autonomous system 20. Now, when 4.4.4 is advertised from R4 to R2, sorry, to R3, R3 will learn like this. R3 will say, router 3 will say, 4.4.4.4, I have learned it from whom? I learned it from 34.0.0.4, this address. Because it's coming from R4, I learned from 34.0.0.4. Now R3 and R2 are IBGP neighbors. Likewise, R3 and R1 is also IBGP neighbor, fully mesh. R3 and R1 is also neighbor. R2 and R3 is also neighbor. R1 and R2 is also neighbor. So fully mesh. BGP is running everywhere. IBGP to this router, and it is EBGP to this router. Right. So now R3 will advertise this route to R2. Now, how R2 will learn this? R2 will say that I learned 4.4.4.4, from where? From 34.0.0.4. Actually, it is learning from where? 23.3. It is learning from router 3. But the source address will not be changed by default. It will be carried. EBGP's address will be carried when it is advertised to another IBGP. Likewise, when R2 advertises to R1 or when R3 advertises to R1, because this is fully mesh, because there is a split horizon issue, R3 will give directly to R1. So when R1 receives the update, that also will have the same information, 34.0.0.4. Now you see, when I ping from here, router 3, when I ping from router 3, I can ping 4.4.4.4. I can. Why? R3 knows how to reach this 34.0.0.4. Now we run OSPF only in this autonomous system. We are not running OSPF on this 34 network because it is different autonomous system. So this router R1 and R2 has no idea where this address is. It has no idea where this address. It is learning from here. Through BGP it has got the update, but R2 has no idea how to go to 34. Because we don't run OSPF in this link, because it is between two different autonomous systems, R2 and R1, they don't know where is 34.0.0.4, even though they got the route in their BGP table. Very important. Even though R2 and R1 has got the information about 444 on BGP table, it will not be seen in the routing table. Why? Because it don't know from where I am really receiving it. Who is 34.4.0.0.4? No idea. Because there is no idea from the to reach the actual source, it is not considered as valid and best. It is simply valid. You know, in the videos, if you see, we have star here. Star means valid, learning from BGP. But to see the route in the routing table, just valid is not enough. It needs to also have best. This is the symbol for best. If you don't have the symbol, then that route is not best. If it is not best, it will not be seen in the routing table. Just valid, not best. So this route will not be there seen in the routing table. So you cannot ping from R1 to R1 and R2. You cannot ping from R1 to 4444. You cannot ping from R2 to 4444. Why this problem happened? Because of this unreachable address, unreachable next hop address. Unreachable next hop address. By default, this is how it is. This is how BGP is designed. When a route is learned from an eBGP, the eBGP's address is carried inside IBGP. The eBGP's address is what here? 34.0.0.4. It is carried without changing. R3 will not put its own address. R3, while sending the update, it will carry the same address. It won't change. R3 will not put its own address. It will just carry the same address from where it is coming without changing the next hop address. Because of this, we face this problem. Now, what is the solution for this problem? We need to make R3 to change the address. We need to make router 3 to put its own address. If R3 puts its own address, R1 knows how to reach 23.0.0.3 because you run OSPF. R2 knows how to reach 23.0.0.3. So we need to make R3 to remove this address and put 23.0.0.3. That solves the problem. Now, if I ping from R1, R1 will send it to 23.0.0.3. How? By looking into the routing table. OSPF says 23, you send it to router 2. Router 2 will say send it this way. It goes to router 3. And router 3 knows where is 444. It delivers to router 4. So what's that we need to do? We need to make R3 to change the next hop address, to change the learned address. How to do that? We have a command called next hop self. We need to go to router 3, and under the BGP we need to say neighbor router 2's address 23.0.0.2. This is router 2's address. To this neighbor, I myself is the next hop. Next hop self. I need to do this on router 2. Likewise, neighbor 12.0.0.1. Who is this? This is router 1. I need to do on router 3. I need to go to the same router 3, and also say whenever you send an update to 12.0.0.1, put your own address. Don't carry the address that is coming. Put your own address. That's the meaning here. Next stop is you yourself. So when I say this command, R3, before sending the update to R1 and R2, it will put its own address, which is a reachable address for router 1 and router 2, and R1 and R2 can have this router not just valid, it is also now best, because it has got a reachable next hop address. Because it is valid and best, it will be seen in the routing table and you can ping now. Very clearly these things are explained. So please go through those videos and finish these things. Now next, what we will be seeing in the next classes, I'll stop here itself because you have a lot to watch from more videos and practice. So I want you to finish and come. I don't want to stuff too much thing. All that we learned here today is very, very important. Core knowledge about BGP. Most of the people think BGP means attribute is very important. If I know attribute, I know BGP. No, that is okay. That is also true, which we are going to learn in coming days. Within this week, we will finish BGP, and then we'll get into switching and finish CCNP maybe by next week. But very important is this. Most of the people don't know what split horizon in BGP means, why we have that, why it needs to be fully mesh, all those things that we discussed today. And next hop self, some people know that next hop self. Some also knows about the previous class. You remember eBGP multi-hop. Those things also very important. Now, the next class we are going to learn is, in order to form a neighbor with multiple peers, in order to form neighbor with multiple peers, we can create something called templates by using peer group. So we will be dealing with peer groups. I'll demonstrate definitely this one, in which I'll be covering all that I explained today. But I also want you to finish the video that I give you. Though I'm going to do it on next class, all this which I explained, I'm going to do the lab. I want you to go through once before you come to the next class. That will really make your study more comfortable. So peer group we will do. It's a template that we create so that it will be easy for us to form neighbor with multiple BGP peers and less number of commands, less number of codes. So BGP peer is one topic that we will learn, and we will get into BGP path, which is very important. That is called attributes, in which we will be learning all attributes. Plus we will also learn something called route map in it. Route map is not BGP, but route map can be used with BGP. So parallelly we also learn about route map and BGP attribute. When we do this, we actually finish CCNP, but we'll be also seeing something more, little extra called BGP route reflector called RR and BGP configuration. So when we do these four topics, we are finishing our CCNP BGP. Now today one more small topic I want to cover and then we'll finish. Let's say I got two routers R1 and R2 on two different autonomous systems. This is autonomous system 10, 20. Two different autonomous systems. Now let's say we have many number of routes coming from router 2. X, Y, Z, many networks are coming. Likewise from R1, many networks are coming to R2. Alpha, beta, gamma, many networks are coming. Now before forming neighbor, before learning the routes from the neighbor, I want to authenticate. I want to authenticate R2 before taking the route from R2. Likewise, R2 wants to authenticate before taking route from R1. Is it possible to authenticate in BGP? Yes. BGP authentication is the simplest authentication. Let's say here our address is 11.0.0.1. Here our address is 11.0.0.2. Now on R1 what we say? R1 config T. We will say router BGP 10 will be inside the router mode. We say neighbor 11.0.0.2 remote AS 20, and then we say neighbor 11.0.0.2 password. See how easy it is. Password. You give the password 1 2 3 ABC. This is the password. Same way you go to router 2, say neighbor as 11.0.0.1, remote AS as 10 because 11.0.0.1 is in 10, and then say neighbor 11.0.0.1 password, same password. That's all. Authentication over. Both the side password should be same. Now when I give this password, the password is not sent as plain text. It is not sent as plain text. Passwords are sent as hashed MD5 ciphertext. They are sent as encrypted. So in a more secured manner it sends. Both the side we should keep the same password, only then both the side hash values will match. This is the easiest authentication in any routing protocol. When you compare to other routing protocol, BGP authentication is the easiest one. Now if I want to advertise a network 2.2.2.2, you know the command. If this is /24, assume. Is 24 default subnet mask? No. 2 means class A. The default subnet mask is /8, class A. But it is subnetted. If it is subnetted, if it is not class full, when you advertise network, not neighbor, network command. Okay. Let's say I have here 1.1.1.1 /24. So I'm on router 1. If I want to advertise R1 to R2, if I want to advertise 1.1.1.1 to R2, all I need to do is I need to say network command, not neighbor command. Neighbor command will not advertise any network. We say network 1.1.1.0 because it is 24 mask, because it is masked, because it is subnetted. I use the mask command and say 255, no wildcard mask, only subnet mask, 0. Let's say I have a network here, 111.0.0.1/8. What class it is? It is class A. Is it subnetted? No. If it is not subnetted, if you want to advertise, you simply say network 111.0.0.0. No need of saying mask. If it is default subnet mask, don't say it. If you say nothing wrong, but it's spaced. If it is not default, we must use the mask command. This is not in any other routing protocol. We don't use this command in any other routing protocol. Must type mask command and then advertise. Network command will advertise the network. Neighbor command is just for forming neighbor. These networks in the neighbor statement will not be advertised. More security here. Whatever you allow to advertise, only advertised. Whereas in other routing protocol, wherever you use the network command, all will be advertised. There is no neighbor command. So even the network that you don't want to advertise, it will be advertised because you want to run OSPF here. If you want to run OSPF here, you will say network 11.0.0.1. So 11 will be advertised. Whereas in BGP, whatever you want to advertise, only that you advertise. So whatever you use in the neighbor statement will not be advertised. This is more secure. So please go through these videos that I am going to send you just after this session and come back next class. Next class is very important. We'll finish peer group and I'll demonstrate it, so it will take time. Peer group and the demonstration. I will also give a very good introduction on BGP path tomorrow. And day after tomorrow we will finish the lab on BGP path, and then the following day we will finish this too. When we do that, we finish our BGP CCNP. So definitely we are finishing BGP this week, and the next week we will be having switching, and that's how we finish our CCNP. We won't have much in switching, so within a week's time we can finish complete switching. Anything you want to ask before we close? A CEF is a part of layer 3 switching. Sorry, layer 3 switching. It is there in switching topic. It is coming in the next week. RIP, I think you learned in CCNA, right? IPv6 RIP. No problem, I can teach you. That's not a problem. IPv6 RIP is what? RIP NG. Enabling IPv6 on RIP. It won't take much time. We'll try to finish that on Friday itself, this Friday itself. Yeah. Then I'll do one thing. I'll teach IPv6 OSPF all in one day. IPv6, OSPF, EIGRP and RIP. Even BGP also. Right, that can be done in single day. Alright, anything else? Right. Ma'am, do you have any question?